What's up, Einsteinatics? You're still with me, Sir Janus. Today, we are going to energize our minds with concepts of atoms, elements, and compounds. If you're new to this channel, please make sure to subscribe and ring the bell to be notified of more videos. So let's get started. Let's kick off the topic with understanding of elements and its properties. Specifically, we are going to take up concepts of atoms and substances, which is very much essential if you are going to have a clear grasp or understanding about elements and compounds. Please do remember that all substances on Earth or the whole universe are made up of atoms. All substances are made up of tiny particles called atoms. Water is made up of hydrogen and oxygen atoms. A car, for example, is made up of several atoms such as iron, aluminum, silicon, oxygen, and boron atoms. A plant is typically made up of carbon, nitrogen, hydrogen, oxygen, and sulfur atoms. You might be wondering that if atoms makes up all materials in the universe, then what atoms make up a human? Typically, the largest component for a human is that we are made up of 65% oxygen, followed Now, let's proceed with elements and its properties. So you might be wondering, what is an element and what is its relation to an atom? Do remember that when you talk about an element, remember that it is a substance that is made up of only one type of atom. Elements are the simplest substances in the universe. Take this material as an example. Copper is an element made up of copper atoms only. And when you talk about carbon, this is an element which are made up of carbon atoms only. Same goes with helium. It should be made up of only helium atoms only. other definition for elements is that it is a pure substance. When you talk about pure substance, it's that it is unique materials wherein it has its own set of properties and composition that do not change from one sample to the other. Have you ever wondered who discovered the elements? Actually, some elements such as silver, gold, and others have been known and used by many people for centuries. However, many of the elements were only discovered in the 18th and the 19th century. One of these is the discovery of oxygen when British scientist Joseph Priestley experimented with heating gases. At the start of the 20th century, Marie Curie and other scientists discovered radioactive elements such as polonium and francium. So how many elements are there? There are currently 118 elements that had been discovered, 94 of which are naturally occurring. The remaining 24 elements only exist under laboratory conditions. Can you name some naturally occurring elements? Can you give an example? Okay, so some examples of the naturally occurring elements are gold, copper, xenon, chlorine, iodine, and bromine. You should remember that most artificial elements are very unstable, meaning they usually only exist for milliseconds before About ductility, it is the ability of a substance to be stretched into a wire. Another physical property of elements is what you call as malleability. When you talk about malleability, it is a physical property of metals that defines their ability to be hammered, pressed, or rolled into thin sheets without breaking. In other words, it is the property of a metal to deform under compression and take on a new shape. Take this gold as an example. Gold, by hammering, can be formed into thin sheets. So how would one differentiate between malleability and ductility? Actually, it is quite easy. If a metal can be stretched into wires, then that is ductility, or the metal is ductile. On the other hand, if the metal can be pressed into thin sheets, then that particular metal is malleable. Now let's proceed with the chemical properties of elements, meaning these are the properties of elements which cannot readily be observed just by using the human senses. The first chemical property of elements is known as combustibility or flammability. This refers to the ability to be burnt easily or undergo combustion. Another type of chemical properties of elements is what you call as oxidation. When we talk about oxidation, this refers to the rusted or being oxidized and form oxides. Here is a clear example as to how metals would react to the environment exposed to oxygen. Another chemical property of elements is what you call as toxicity. This refers to the relative degree of being poisonous. Next chemical property is what you call as acidity. This refers to the state of being acidic by nature, which is usually measured through the pH meter. The last chemical properties of elements refers to the resistance to chemical change or to physical disintegration. This is known as stability. Now let's explore the symbols for elements. We are going to determine how the symbols are generated, what rules are being followed in writing the symbols, and what purpose does it serve. Each element can be represented by a symbol. Usually, the symbol is the start of the name. For example, H for hydrogen, Li for lithium, O for oxygen. Can you think of any other symbols like this one? So, as you might have guessed, a lot or majority of the elements written in the periodic table are written this way. They follow the first or the second letter to signify the symbol of that particular element. However, you might have also noticed that some of the symbols are not always as you might expect. For example, Pb for lead. You have also other examples such as Au for gold, Ag for silver. Can you think of any other elements with unexpected symbols? So we are going to discuss more of that later on. Now, for a particular element, it is always written in a capital letter. That is very important. If there are two letters in the symbol, the first one is letter in capital, while the other is in small caps or in small letter. This is not to confuse. For example, for cobalt is capital C and small letter O. You should not write it this way because this one represents two elements now, carbon and oxygen, and not anymore a symbol for cobalt. So here are the examples of elements that do not follow the first letter of the symbols. This is because their names or the symbols are taken from their Latin name. For example, sodium has the symbol Na because it is taken from its Latin name natrio, together with the potassium, iron, copper, silver, gold, mercury, lead, and tin. Have you figured out why are symbols important? So why might scientists find it easier to use symbols for elements rather than names? As you can see, elements have different names in different languages. For example, in Portuguese, nitrogen is called azote and iron is called ferro, which will cause confusions if we are going to use this one in its native languages. Aside from that, symbols are quicker to write the names and can be easily used in chemical formula, diagrams, and equation. So when you talk about carbon dioxide, you can easily write it by its symbol CO2, for water H2O, and for salt, sodium chloride can just be simply written as NaCl2. Now this has been taken from the International Union of Pure and Applied Chemistry, or IUPAC, so that scientists all around the world could communicate without confusion. Please do note that there are many different materials in the world, but only around 100 elements, or 118 to be exact. These elements can be combined in many different ways to make thousands of compounds. So what is a molecule? This is when atoms in some elements join together. So one element that exists like a molecule is hydrogen. Each hydrogen atom joins up with one other atom to make a hydrogen molecule, such as this example. So if it is consists of only one, this is a hydrogen atom, but when it combines, this is already known as a hydrogen molecule. Now, the formula for hydrogen molecule is H2. Other elements such as nitrogen, oxygen, and chlorine also exist as molecules. And what do you think are the formula for these elements? We are going to find it out later on. Just a while ago, we have discussed how to write the symbols for elements. Do you still remember it? The first rule is that the first letter should be written in capital, and if an element is consist of two letters, the first one is written in the capital and the small one should be written in a small letter. Now you might be wondering how to write the symbols for molecules. Okay, you are going to combine the symbols of the atoms in a molecule that would give you now the formula to the molecule, such as these examples. For the oxygen molecule, hydrogen molecule, and the nitrogen molecule. Now, as you can see here, the letter denotes now the type of element it consists. This one, the number here, subscript, represents now the number of atoms that makes up the molecule. Okay? Can also exist as molecules. Here is an example. Water is made up of hydrogen and oxygen atoms. Do you have any idea about the formula for water? Okay, so we are going to answer that one later on. On the other hand, carbon dioxide is made up of carbon and oxygen atoms. What do you think is its formula? Any guess? Okay, so water has the formula H2O, wherein it shows that it is made up of two hydrogen atoms and one atom of oxygen. On the other hand, carbon dioxide is consist of one atom of carbon and two atoms of oxygen. Hence the term carbon dioxide, which means two atoms of oxygen. please do remember that compounds are not mixtures. Because, take for example, water is a compound because it is made up when hydrogen and oxygen reacts and their atoms becomes chemically joined to each other.